So, it is called as working stress, that the stress to which material may be safely subjected in the course of ordinary use. When designing the machine parts, it is desirable to keep the stress lower than the maximum stress at which the failure of the material takes place. This stress is known as working stress. It means, or we called as, it is known as safe stress or designing stress or allowable stress also. The next stress is your yield stress. Yield stress is the stress at which that the material deforms permanently. It means the point at which the stress increases faster rate at any increase is known as yield point. Every material or every machine component have the yield point, where in that point we increase the load or we increase the stress, that is called yield point, and the corresponding stress is known as yield stress. The next part is ultimate stress. What does that mean? The ultimate stress is the maximum value of stress that a material can resist. It means it is known as also the maximum stress. When we give a stress to a component or a machine component, or when we give the maximum stress, it is known as ultimate stress, and the material have to resist the ultimate stress in this body. The maximum value of stress at which the deformation takes place, also known as ultimate stress. Here it is known as ultimate stress, and the next part is your factor of safety. We have studied the factor of safety in your theory of machine chapter also, but this is the factor of safety in your machine designing topic. And the factor of safety is defined as the ratio of maximum stress to the working stress, and it is mathematically defined as, that is, F dot O dot S is equal to maximum stress by working stress. In this factor of safety, there are two cases also. In case of ductile material, that is the one, and the two is in case of brittle material. In case of ductile material, the factor of safety is equal to yield point stress by working stress. And in case of brittle material, the factor of safety is ultimate stress by working stress. So the factor of safety have the 2 points, that is, one is ductile material and another one is your brittle material. Here we go for the mechanical properties. We have studied the properties of material in your engineering material topics, and here the short points of the properties of material I have discussed. First is your strength. What is strength? It is the ability of a material to resist the externally applied forces without breaking. Next is your stiffness. It is, in this case, the stiffness is defined as the ability of a material to resist deformation under stress or under load. Next is your elasticity, or you can say as your elasticity limit. Every component has an elasticity limit, and that is called the point of elasticity. It is known as property of a material to regain its original shape after deformation. Next is your plasticity. What does that mean of plasticity? It is a property of a material which retains the deformation produced under load permanently. Next is your brittleness. Brittleness is the property of breaking a material with little permanent distortion. When we give some stress or when we give some load, the material starts to break, or the material starts to break. It is called brittleness. It also have a limited point in every component. Next is your malleability properties. What does that mean? The property of a material which permits materials to be rolled or hammered into the sheet or into a thin sheet. Next is your toughness properties. It is the property of a material to resist fracture due to high impact load. It means when we give some impact load or suddenly applied load, the material started to fracture or it can resist at a toughness point. It is called as the properties of toughness. The next properties is known as resilience. It is the property of a material to absorb energy and to resist shock and impact load also. The toughness and resilience have a minor difference that in your resilience properties, here we can apply the shock load, but in your toughness property, we can apply only the impact load. So the property of a material to absorb energy and to resist shock and impact load both is known as resilience properties of a machine component or resilience properties of a material. Hardness. Hardness is called the resistance of metal to attempt to deform it. And the last part is creep. If a metal is subjected at high temperature, it will undergo a slow deformation. It is known as the properties of creep in a material, or this is called the creep properties in a machine component. Here we are going for the general procedure of machine designing. It means when we design a machine or when we design or draw a machine component, what points should be noted as to proceed. So this is a table that is general procedure of machine design schedule. That is, first one is your need or aim. Second one is synthesis or mechanism. After the mechanism part, we can go for the analysis of forces of the material. Next is your material selection. Next, design of machine element. After the designing of machine, we have to go with the modification of the machine. Next is your detailed drawing of the machine, and the last part is your production. After this point, after this all the points, we have to produce the machine component or design of the machine. So here is the table or the structure of a general procedure of machine designing. So this is the explanation of this procedure. The first procedure was that our need or aim. First of all, make a complete statement of the problem. It means we can indicating the need or aim or what is the purpose or which machine is to be designed. In this first point, we have to consider it. Next point is your synthesis or mechanism. Select the possible mechanism. It means select the possible mechanism or group of mechanism which will give the desired motion or operation of the machine. This is the second point, or after the aim or need, we have to consider the synthesis or mechanism of the machine design. Next one is your analysis point. What does that analysis point or what we consider in this analysis? It means the analysis of force of the machine. Find the forces acting on each member of the machine and energy transmitted by each member. Find the forces acting and energy transmitted. It means the forces acting on each member of the machine and energy transmitted by each member is known as analysis of a force. It is an essential point to consider when we design a machine component.